Let's do this all over again. Okay, so I'm actually not disappointed that I went that way, and I actually feel like I have done it that way in the past, but it was purely accidental. Must have been Monday morning and I was half asleep. So let's go back to 7.2. Okay, so the general form of a linear equation, I mentioned this yesterday, is ax plus by plus c equals 0. So within this equation, a, b, and c are just values, numerical values. X and y represent all of the coordinates on the graph. And the c value, all right, sorry, the a, b, and the c value are just numbers that are whole numbers or fractions or whatever. It says to graph an equation in general form, determine the x-intercepts, then draw a line joining the intercepts, convert to slope point form. Okay, so long and short of it is this. Let's say I was asking you to graph a general equation. So I'm going to create a general equation right now. And I'm asking you to graph this equation. So in its current form, in the current form it's in, it's very difficult to graph that equation easily. So how do I do it, or how do I get it so that I can graph that equation in a simple way? Well, I basically say, I would tell you, you have three ways in which you can do it. The first way you can do it is just simply find your intercepts. So put 0 in for x, 0 in for y, and so for the other. That's, to me, one of the best ways to do it. The second way to do it is just to make a table of values. Find two coordinates and then graph them and then draw the line through them. The third way to do it is to change it into y equals mx plus b, into your slope-intercept form. So I'm going to graph this three different ways and get the exact same graph in all three ways. So the first way I would do it is find my intercepts. So I'm going to put 0 in for x and solve for what y is. So I'm going to rewrite that over here. 2 times 0 plus 3y add 6 equals 0. 2 times 0 is, 2 times 0 is 0. 3y add 6 equals 0. I'm going to subtract 6 and divide by 3. So I'm going to get y is equal to -2. So when x is 0, y is -2. So that's my y-intercept. That's where the graph is going to cross the y-axis. The next way I'm going to do it is I'm going to put 0 in for y. I did it again. The struggle's real today again. 3 times 0 add 6 equals 0. So I'm going to get 2x plus 6 is equal to 0. X is equal to -3. So my x-intercept occurs when y is 0. All right. So now I have two coordinates. I have 0 and -2, and I have -3 and 0. So I can now graph that line. Draw it out. Let's go back. So I want 0 and -2. Right here. And I want -3 and 0. Right there. And then I draw my line between them. So now I've graphed 2x plus 3y plus 6 is equal to 0. That's the graph of that line. So that's method number 1. I love that method and I use it all the time if I have one thing, if that's important. When I look at the equation, I know that I have to divide, when I'm finding my intercepts, I know I have to divide by a 3 and a 2. And because they both go into 6, those work out to whole numbers. So that's really beneficial. I don't have fractions. It works out a lot. It works out very neatly that way. So that is one way in which I will graph a general, an equation, a linear equation in general form. Okay? So that's the first way to do it. The second way is to do it again. You can make a table of values. You can put whatever value you want in for x, and you could solve for y. So it doesn't matter what values I put in. So I'm going to put in 0, and I'm going to put in 1, let's say. Okay? So I put in 0 for x. I know it equals to -2. I've already solved for it. Now I'm going to put a 1 in for x. So 2 times 1 plus 3y add 6 equals 0. That gives me 2 plus 3y add 6 equals 0. 3y plus 8 equals 0. Y is equal to -8 over 3. So now I'm dealing with a fraction. So it doesn't work out that great, but it's still on the line. So if I skip back over to my line, that value is right here. It's still on that line. It's at 1 and -8 over 3. Okay, so it doesn't work out to a whole number, but it's still on this line. So then I could draw a line between them, and I've got my line again. So this second method is a table of value method. It's very beneficial when you're graphing not necessarily linear equations, but polynomial equations. This works out a lot better. If you're unsure of how the graph looks, I always go back to it and say, okay, we'll graph a table of values of your equation, and you'll come up with a possible solution. Okay, so that's method number 2. So find your intercepts, do a table of values, or put it into slope-intercept form. So let's look at that now. So my equation was 2x plus 3y add 6 equals 0. And I want to get it into y equals mx plus b. Okay. Just 1 second here, sorry. All right. So I need to get y by itself. So I need to move everything from the left side to the right side that doesn't include y. So I am going to subtract 2x and subtract 6. That way I get the 3y by itself on its side of the equation. Okay. And then divided by 3. So I get -2/3 x subtract 2. All right. So now that I know that, okay, looking at that equation right now, girls, what's the y-intercept?
-2.
-2. So I go to 0 and -2, which is right here. And then what does my slope tell me to do? What's my map say?
Go down 2 and go right 3.
Awesome. 1, 2 down, 1, 2, 3 over to that coordinate right there. And then I could draw my line through there again. And I have the exact same line. All right. So this is the slope-intercept form. That's the form that I really like the best. Okay, because I can use it in all equations. It's easy to get to. And the only time it becomes a little bit more difficult is if my y-intercept's a fraction. But basically all I have to do is count from that and move from there. Okay, so let's look at your example in your book. So it says, consider the linear equation y equals negative 3 over 2x subtract 3. So y equals, very similar to what we just did, negative 3 over 2x minus 3. So very similar equation. And then it says, all right, write the equation in general form. All right, so one of the things that I said yesterday that's important is in general form, I do not have fractions. No fractions in general form. So the first thing that I would do is if I'm working with this, I'm going to rewrite it over here, is get rid of the denominator on my fraction. So how do I get rid of the denominator on my fraction? What do I have to do? How do you get rid of any denominator? Okay, let me ask you a different question. What does that line mean right there? Between the 3 and the 2, what does that line mean? Divide. So what's the opposite of divide? Times. So to get rid of any denominator, I can multiply by that number. But what I do to one, I have to do to all. So I'm going to times this by 2, times this by 2, and times this by 2. That 2 divided by 2 cancels. So I'm left with 2y equals negative 3x subtract 6. All right. Then the last step in this is to get everything on one side and equal it to 0. So I've got the y by itself here. I'm going to subtract it to this side and get it equal to 0. So I go 0 equals minus 3x minus 2y subtract 6. In this whole section, that's probably the one thing that's going to create the most amount of grief for you. All right, is just the algebra that it takes to either go from slope-intercept to general form or general form to slope-intercept. That might be the only thing that you have difficulties with. Okay, so that's 1A. 1B says, how many intercepts will this graph have? How do you know? And explain how you know. Okay, well, a line, if it's a line that goes on an angle, on a diagonal, whether it's going, let me just draw it. Whether the line goes this way or this way, doesn't matter which, you're going to have one x-intercept and one y-intercept. Okay? You'll notice that it crosses right here and it crosses right here. So that's your x and your y. So the answer to that question in B is, how many intercepts will this graph have? It will have one x-intercept and one y-intercept. C, sketch the graph using the x-intercept and y-intercept. Okay, so I'm just going to get this out of here for a second. And it wants us at this point right here to find my x and my y intercepts. So to get my intercepts, I have 0 and 0. Okay, I put 0 in for x and I solve for y. So I have minus 3 times 0. Subtract 2y, subtract 6 equals 0. That leaves me with minus 2y subtract 6 equals 0. All right, because 3 times 0 is 0. Add 6, divide by negative 2. My y-intercept is negative 3. Now here's a question for you. My y-intercept is equal to negative 3, correct? Does that match up with what it says up here? Yeah. Okay, so now I'm going to put 0 in for y and solve for x. Add 6, divide by negative 3, that's negative 2. So there's my two intercepts in this question. All right. So now I can sketch it. So what I need in order to draw any line, I either need two coordinates, which I can draw a line through them, or I need one coordinate and the slope to find out how to get to the next coordinate, which essentially then gives us two coordinates. So in this case, I'm going to graph my two intercepts. So intercept number 1 is 0, negative 3. Intercept number 2 is negative 2 and 0. And I draw my line through them. So this was negative 2 and 0. This was 0 and negative 3. Okay? Now the original equation they gave us was this. So, what's my starting coordinate? If I'm going to graph using the slope-intercept form, what's my starting coordinate? Yeah, my coordinate. So if I ask you, so you did a great job because you said negative 3, which is exactly right. If I ask you for a coordinate, you should give it to me as an x and a y. If I ask you for the y-intercept, you just give it to me as negative 3. Okay, now it seems really minuscule, and it really is. But in grade 12, we start to, we have to answer the question the proper way. So I'm just pointing that out. But you did exactly what I asked you. You told me where the y-intercept was. 0, negative 3. Now, where does my slope tell me to go?
Go down or up 3.
Okay, it's a negative 3 over 2. So which is it? A negative 3 on top.
So down.
Down 3. And over.
Right 2.
That's exactly correct. And there's my line right there. I've already got it drawn. Goes right through those two coordinates. Okay? All right, how are we doing?
Good.
Yeah? Okay. All right. Okay, I'm going to look at D and E now. Okay, D says this. Explain how the equation 3x plus 6 equals 0 differs from the linear equation in part A. So let's have a look at part A. So in part A, I have negative 3x minus 2y minus 6 equals 0. I'm going to make a note of this because everybody always wonders what happens. If I change all three of these signs and I rewrite it like this, 0 equals 3x plus 2y plus 6, those are the exact same equations. As long as all three signs are exactly the opposite of the signs that they are in the other equation, those are the exact same equation. Okay? So right here, I have 3x plus 2y add 6. So in the equation in the book in D, hi Emma, there's 3x plus 6 equals 0. So how is this equation different? Well, it doesn't have the 2y in it. The 2y comes out of it. So then it says, okay, well, I want you to graph 3x plus 6 equals 0. All right. So I need to graph 3x plus 6 equals 0. Well, I don't have a y in here. I don't have a y in here. So that causes a problem. Right? It appears to cause a problem because every equation I've done so far has had an x and a y in there. So now, if I solve this, I'm going to get x equals negative 2. So what you have to figure out, or you have to see here, is it doesn't matter what y is, x is always going to be equal to negative 2. So what does that look like when I graph it? It looks like this. This is the graph of x equals negative 2. It doesn't matter what y is, x is going to be equal to negative 2. It's a vertical line that goes straight up and straight down. And it goes through x equals negative 2. And then if you look at the E part, it asks how 2y plus 6. So it wants us to graph 2y plus 6 equals 0. Now there's no x here. So I get 2y equals negative 6. Y is equal to negative 3. So what is that line going to look like? If x equals negative 2 is a vertical line, what do you think y equals negative 3 is going to be?
The same, but like along the y-axis.
Yes. It's a horizontal line right through y equals negative 3. That's it there. Like that. Okay? How's that, girls? Are we all right?
Yep.
Okay, I had Emma on here for a second, but I lost her. Okay. So that basically takes care of all that you need in 7.2. So if you want to go back through and start 7.2, okay, I'm going to look at question 1 with you, just to get you started. So I want to look at 1A. Okay, so 1A says, can you turn that into general form? So what's the first thing that I mentioned that we want to do to get it in general form? What do I have to do first here? What do I not want to have?
Fraction.
A fraction. So what do I got to get rid of?
1/3.
Yeah. So I'm going to multiply each value by the denominator. That way that gets rid of my denominator. So I get 3y is equal to x add 15. So that's the first thing I want to do. And then at that point there, I want to move everything to one side. So it's easiest just to move the 3y. So I'm going to subtract it to the other side. I get x subtract 3y add 15. All right?
Yep.
Okay. So rather than asking you about yesterday's work, because we kind of went ahead of the game, we'll finish up 7.2 today. So it's actually a shorter section. And then we'll look at 7.3 again tomorrow. Does that sound okay, girls?
Yep.
All right.
Wait.
Oh, who we got on here? Hi, Myra.
Hi.
How are you?
Good.
You're just chiming in as we're exiting, but what would you, do you have any questions that you want to look at?
No, I was just checking in to see if you got my assignment that I emailed you.
I absolutely did. I hope to get it marking those. I'm actually going to mark these assignments today, and I hope to have them back for you tomorrow. And I will likely go through. I'll probably wait till Thursday. Thursday, I'll go through those assignments with everybody, and I'll have them on here. Okay.
Mm-hmm.
Yeah, I need to email people back when I get their assignments. I got to get better at that for sure. Although I'm actually going to change it up. I'm going to change it up though. We are going to attempt. This is going to be my OneDrive failed. My attempt at a OneDrive failed. So now I'm going to post the assignments on Teams, and you should be able to get them off of Teams and put them back into Teams. So that's. We're going to try that at the end of the week, and I hope that works a lot better because I'm still getting a lot of pictures, and I'm having to piece together assignments and figure out whose is whose.
Yeah,
and
it's just hard. Like the first assignment you gave us, I could open it. The other ones, I couldn't open it and like type in it in Word.
Right. Well, yeah, I don't want, because I'm sending them all as PDF files. Basically, what I want you to do is just do what you're doing. Take a picture of it, or if you can print it off and write on it and then take pictures after, that's perfect. I don't expect you to type in them because it's math. It's too hard. It's too hard to type into the math. So if you want to just continue to do what you're doing, if you can turn it into a PDF and then return it to me, that would be ideal.
Okay, how do you do that?
Well, there's an app on your phone that you can use that will take pictures and turn them into PDFs. That's one way to do it. You can also look for a scanning app. They're all free apps, but there's a PDF scan app on there. You can try and find it as well. If you can't make it work, I totally understand. And you can just take pictures and then put the pictures back in. But if there's a way you can convert them, that would be the best situation for us.
Okay, I can try and print it off, but my printer doesn't always work.
Okay, no,
I won't print it. I don't know why it's gonna.
You know what? That's okay. You continue to write it on paper. That's fine by me. I don't have a problem with it. I would just if you're sending it back, if you can attempt to send it back as a PDF, that would be better for me. If you can't, it's okay. It's working the way it is.
Okay.
All right. So you're gonna put it back into the Teams folder when you're done with it.
Okay.
All right. Jake?
Stop. Sorry, my
Sorry.
cat is.
That's all good. Okay, so girls, do you have any other questions this morning? So we just finished 7-2 today, Myra. I actually I skipped it yesterday by accident. So we went back and did 7-2 this morning. And we'll work on 7-3. Okay. We'll do 7-2 today and 7-3 tomorrow. Okay?
Yep.
All right, girls, any other questions? No?
No.
Okay, excellent. Well, we'll see you tomorrow morning. Let me know if you have any difficulties, and have a good day. Okay?
Yeah, you do.
Okay, bye, girls.
Bye. Bye. Bye.
Straight.